Hello, chemistry teachers. How are you guys? Welcome to our final video in our five-part video series. Understand the whole curriculum. And now this one is putting it all together. Here is an example lesson plan for you guys to demonstrate how to use all the stuff from the curriculum and how it can be really engaging. I'll go ahead and start sharing my screen right now. And this is, you guys can use this lesson plan as is. You can be inspired by it and do your own thing. I just wanted to demonstrate how I envision people using the curriculum map and resource to create pretty engaging and dynamic lessons. I don't want this to feel like you just assign things to students and then have them go work. You're creating a classroom of learning with different teaching strategies involved. So I will go ahead and walk through this example lesson plan. Try to do it pretty efficiently so the video is not too long, show you where everything came from. So I'll bounce between this, which is the lesson plan. Check the description in the video if you want this document. You can print it out and have it while I go through this video. I'll also be flipping over to our curriculum map, any of the resources there. I'll zoom in so you guys can see everything on the screen. Okay, to start off with, this is not a special lesson plan template. It's just a default Word one. So feel free to not use this, but just use whatever your school uses. But for the filling out your objectives and standard, which most lesson plan templates need, I just come down to I was doing at the beginning, the atomic theory, and I just found my objectives here and my standard here, whichever one was applying to my lesson, and I filled that in. So that's where that came from. I kind of picked a couple of objectives for the purposes of this lesson. Down here is where the actual lesson, keep finding typos as I do these videos. The actual activities for the lesson are down here, and I've got it broken down into two columns. The left column is what am I doing as the teacher? What do I need to get prepped for the students? And then the right side is here is what the students doing during each of those activities. So as I go down, I'll kind of reference both sides of this, and I'll jump over to the curriculum map to show you guys where I found various documents. But I'll basically be sticking right here. I think I picked everything out of this whole area right here. And the unit phenomena, which is from up above, but still listed here. So let's go ahead and get started. The first activity that I put was I'm going to introduce the phenomenon. So this one, I did this with the class once, really cool. And it's about how small are atoms. This link will take you to a website. You can follow the instructions there. But basically, to help students visualize just how small an atom is, you get them a piece of paper. And then they have to cut it in half. That's one cut. Then they have to cut it in half again, and then again. And each time you're cutting in half, you're going the same way. So if your paper's this way, you do a cut, you do a cut, you do a cut, and you're getting skinnier and skinnier every time you do a cut. Students can get to about 7 or 8 cuts before the paper's too thin and they just can't cut it. It's similar to the Mythbusters. How many times can you fold a paper in half? Similar to that. So then they find out, okay, so I got maybe to 8 times I was able to cut the paper in half. Then you tell your students, if you wanted to cut that paper down until you got down to just one atom of paper, which doesn't really make sense, but just for the purposes of conversation, in order to get that small, you would have to cut it in half 31 times. And you were only able to do it 8. And so that's a pretty amazing concept for the students to realize that is incredibly, incredibly small. There are a ton of other phenomena activities where it helps students visualize just how small atoms are. That one is kind of fun. You get to do little crafts. All the students can be engaged. So I made a couple notes on here, like either I'm providing every student scissors and paper, or I'm pairing students up and they can kind of take turns. So just kind of what do you have in terms of numbers, and then make sure students clean up the mess before we move on. So what I would do is I'd have the students clean up while I set up the next part, which is the intro video. With chemistry and biology as well, I put an intro video at the start of every concept. Actually, it gave you links to all the videos in each concept, and then I picked one that kind of felt like a good introductory one. They're all clips. So I believe this one is about 2.5 minutes, and it talks about the general structure of the atomic nucleus. But instead of just having students watch a video and then move on, I created a kind of interesting activity out of it. So after the video, students are going to go work in groups and they're going to create a poster to demonstrate the parts of the atom and provide details for each of those components. So the protons, neutrons, electrons. So they'll need a model. They'll need to have the details of each of those particles and all the other information from the video. Or you could have each of the groups provide a description of one part of the video, and then everybody would share their ideas and it work together as a whole. Either way, the students now have an end task. Okay, after this video, we're going to have to do something with it. So since they have to take the information from the video to create something, I'm going to encourage students, go ahead and take notes during this video. There's bold text that pops up at the bottom constantly for the important information. So it makes it easy for students to take notes. And then they'll go to their groups and they're going to create a poster. Main things that we're looking for: do they have an atomic model, the nucleus, electrons? Have they labeled that the protons are positive, electrons negative, neutrons neutral? Maybe they include the masses. There's information in the video about isotopes. Maybe they have a description down at the bottom. So now they're going to create a poster, share that out to the class. You can clarify any misunderstandings, or I can fill in any gaps that I notice after that. So now I've taken a 2.5-minute video and I've stretched that into a 10 or 15-minute activity where students are creating documents on the wall. They're presenting to their fellow peers. So kind of a fun and interesting way to kind of take that. And then if there's a really good poster, guess what? We're leaving that one up on the wall. That's going to be our model of an atom that we refer to as we move forward. So kind of a cool idea there. Next up, I found really useful. So in Discovery Ed, there's actually virtual labs similar to what you might find on Gizmos. So if you like the one on Gizmos, this would be a part where you could go, instead of using this, go use the one on Gizmos, or I'm sure Explore Learning PhET has some as well. I'm staying just on the resource Discovery Ed for all of the content for this lesson. This will load up faster for you guys. I'm just recording a video while doing this. So it gives an introduction. So if your students are opening this up, they could read this and it helps explain everything. Very thorough. You've got some details over here for some learning. Let me zoom in just a bit. Oh, that is zooming out. There. And students have the ability to grab protons, they can grab neutrons, they can grab electrons. And it'll let them know if it's stable. The only way that it gets really unstable is if you add too many protons in comparison to neutrons. You can see I can add neutrons. I'm at a stable element. I can't identify it yet. It wants me to make it neutral. So your electrons and protons will always need to balance. And then it'll let me identify what that is. So now I'm sitting there, okay, what has 3 protons and 3 electrons? Let me not embarrass myself, but that'd be lithium. And so once they've identified it, you can also take a look at the tracker. Tracker will list every atom that they've identified. So there's this, which is great. Down here, there's actually a student document worksheet that goes along with it and a teacher's guide to help you. How do I present this in a class? So I would put in my lesson plan to go ahead and start that lab together, make sure that all the students were familiar with using that simulation, probably pair students up for this. And then slowly transition to, okay, now students go ahead and finish that worksheet using that simulation. And then to finish it off, so they're kind of going through answering questions, and then they're finished with that document. Every group, to make sure that I kind of know when people finished, every group I'll assign a different element on the periodic table, because you can get up to like 18 protons on here. So I can assign the groups any element up to element 18, something like that, 18 or 20. And they have to create that element on here and have me verify it before they are completed with the lab. So now they are looking at an element on a periodic table. Okay, now I have to be able to put the right number of protons, neutrons, and electrons on there to create a stable atom, and I can verify that with them. So that's what they'll do to finish off the lab. So that's going to take 30, 40 minutes right there. So we're already well into a lesson here. And then to finish off, so keeping right in line with what they're learning about protons and neutrons, how those all add together. The video covers a lot of this stuff. Now they're going to do the isotope practice problems. So students are probably going to finish the labs at different times. So I have this document ready to go where they probably will be fine without me. So that way I can help other groups finish up the lab while they complete the work. You'll find, let's see here, I listed the isotope worksheet practice here. So I actually did steal something from week 2, but you'll find it in the resource folder. Research folder has all the stuff listed there, as well as anything not linked. So I find my worksheet. And it's actually a pretty basic worksheet, not too bad. They're given the symbol and the atomic number, atomic mass, and they have to interpret this to fill this out. So once a student kind of gets the process, it's not going to take them very long to fill this out, but you'll notice I'm kind of already introducing the idea of isotopes. So here's 2 elements that are the same, but they have a different mass. So our students able to know, okay, well, if they have a different mass, it's the neutrons that are different, not the protons. And so hopefully that they'll be able to work through that. It's just 2 pages. And then I assigned this and I said, okay, if you don't get part of this done, then that's your homework, and bring the rest of it finished when you come back tomorrow. And so they're getting that practice of interpreting this information, similar to what they will see on a periodic table, just listed differently. You guys know what this is called. I'm just blanking on the name. So thank you for your patience with me. But now we're heading up the end of the class period. I got some students finished with the worksheet, some just starting, but we're kind of winding down. But I've made sure, okay, before everyone leaves, they all know how to do this worksheet. So then they'll turn it in tomorrow. And then we'll be able to move on to the next lesson. So everything on here, super modifiable. You can tailor it to what you want. You can bring in outside material and really fill it out. I just wanted to show how this can be really engaging, and students are involved in the whole process, using all the resources from Discovery Ed and the curriculum app. So hopefully you guys found this video useful. Feel free to use that lesson plan however you see fit. And if you need any help planning, just reach out to me. I'd be happy to help. All right. I can't see you at the next video, but I will see you at you guys' schools. Bye.